Students, welcome to the science class. In last session, under the chapter of is matter around a sphere, we studied about types of the mixtures, isn't it? We studied what is solution, what are the types of the solution, what is homogeneous mixture, what is heterogeneous mixture, isn't it? So, in today class, we are going to continue at that part. In last session, we studied last thing, that is the solutions. We have studied the properties of the solution. Next, another one property here. So I am considering another one type of the mixture, that is we are going to calculate here the solubility of the solution. We studied the what is solution in the last session. Now we are going to study solubility. What is solubility? Solubility. Solubility, it is nothing but it is the rate of the amount of the solute particle dissolved in a solution at a given temperature. It is known as the solubility of a solution. What is solubility of a solution? It is nothing but solubility means the amount of solute, the amount of solute particles dissolved in a solution is known as the amount of a solute particles dissolved in a saturated solution. You have to remember here, saturated solution, in a saturated solution. In a saturated solution, the amount of solute particles dissolved in a saturated solution is known as solubility of the solution. See, you have already know about what is a saturated solution. Saturated solution, it is nothing but it is the time at which the solvent doesn't dissolve the solute particles. Why? Because it already fulfills, because it is at the saturation phase. So what is solubility here? The amount of the solute particles dissolved in a saturated solution. At the time in the saturated solution, how much amount of the solute particles are dissolved, that is going to be the solubility of the solution. Have you got understood? What is solubility of the solution? It is nothing but the amount of the solute particles dissolved in a saturated solution is known as the solubility of the solution. We are going to calculate the concentration of the solution. We are going to calculate the concentration of solution in two ways. Concentration of the solution. What is the concentration of the solution? Why we are going to calculate the concentration of the solution? It is why? Because to know whether it is a concentrated solution or whether it is a dilute solution or whether it is saturated solution, we are going to use to calculate the concentration of the solution. Concentration of the solution can be calculated by two methods. First method is mass by mass percentage. Mass by mass percentage. Mass by mass percentage of a solution is equal to mass of solute divided by mass of solution into 100. By using this formula, we are going to calculate the concentration of the solution in terms of mass and mass. And another one way we are going to use here is mass by volume. Mass by volume percentage of solution, percentage of a solution is equal to mass of solute divided by volume of solution volume of solution into 100. By using this formula we are going to calculate the percentage of the solution. We have to remember the concentration of the solution we are going to calculate by using these two formulas. That is, when it is nothing but mass by mass percentage, that is, in that cases, in which cases we are going to use this formula, it is nothing but in the question when they are going to give the mass of the solute and the mass of the solvent or the mass of the solution, we are going to calculate the concentration of the solution or the percentage of the solution by using first formula. If in the question if they are given mass of the solute and volume of the solution, then we are going to use this formula to calculate the concentration of a solution. You have to remember, have you understood? See here, we are going to use mass by volume percentage of the solution is equal to mass of a solute divided by mass of solution volume of solution into 100. If in the question they give the solution in the unit of volume, we are going to use the second formula. So based on these two formulas, now I am considering two problems here. First problem, a solution contains 40 gram of common salt, 40 gram of common salt in 320 gram of water, in 320 gram of water, in 320 gram of water. Calculate the concentration of a solution in terms of mass by mass percentage. Calculate concentration of the solution, in terms of mass by mass percentage. See here, a solution contains 40 gram of common salt in a 320 gram of water. See, they given here the solute, it is 40 gram, mass of the solute is 40 gram, and they doesn't give the mass of the solution, they give mass of the solvent. So solvent, it is nothing, solvent it is present in a solution, solvent, they give the mass of the solvent as 320 grams. So how we are going to get the mass of the solution? By adding mass of the solute and mass of the solvent, we are going to get mass of the solution. And what they are asked here is, they ask mass by mass percent, they are asked concentration of the solution in terms of mass by mass percentage. Solution here, see mass of solute is equal to how much it is? 40 gram. Then they give mass of the solvent here, mass of solvent, here solvent is water, here the solute is common salt, mass of the solvent is 320 gram. Then we need a mass of a solution, mass of a solution is equal to mass of solute plus mass of solution, mass of solvent. We need a mass of a solution because mass by mass percentage is equal to, what is the formula here? Mass of a solute divided by mass of solution into 100. So they give only mass of the solute and mass of the solvent, they don't give the mass of the solution. We have to find out the mass of the solution by adding mass of solute and mass of solvent, that is equal to mass of solution is equal to 40, that is mass of a solute is 40 gram here and mass of a solvent is 320 gram. That is equal to 360 grams. This is the mass of the solution we get. So concentration of a solution, concentration of solution is equal to mass of solute by mass percentage of the by the using formula mass by mass percentage, that is mass of solute divided by mass of solution into 100, that is equal to mass of the solute is here 40 gram, that is 40 divided by mass of the solution 360 into 100. This 0 get cancelled. See, that is equal to 4 9s are 4 10s are, that is we get 100 divided by 9. Why? Because 10 into 10 100, 100 divided by 9, 9 1s are 9 11s are, remaining is 1 becomes 10, again 9 1s are, that is we get 11.1%. Therefore concentration of solution is equal to 11.1%. Is it clear? See, in this way we are going to calculate the concentration of the solution. In your future days, when you are going to make some experiments in the chemistry laboratory, you have to find out the concentration of the solution. In that cases, these two formulas are very helpful. And also for your examination, they may ask such type of questions for 1 marks or 2 marks. You have to remember it is very easiest problems. I am considering another one example here. To make saturated solution of saturated solution 36 gram of sodium chloride is dissolved in is dissolved in 100 gram of water, 100 gram of water at 293 Kelvin, Find its concentration at that temperature. Find its concentration at that temperature. See here. To make a saturated solution, 36 gram of sodium chloride is dissolved in 100 gram of water. 36 gram of sodium chloride, that is, it is a solute. The mass of the solute here is 36 gram. It is dissolved in 100 gram of water. Here water, it is a solvent. So mass of the solvent here, it is 100 gram. What they ask here is find its concentration at 293 Kelvin. So we have to find out the concentration of the solution here. Again, write down the given data. Mass of the solute here is equal to how much it is? That is 36 grams. Mass of solvent is equal to 100 grams, and mass of solution is equal to mass of solvent, mass of solute plus mass of solvent. That is equal to mass of the solute here is, it is 36 gram. and mass of solvent is 100. Therefore, mass of solution is equal to 136 gram. We get now mass of the solute and mass of the solution. Now we are going to calculate the concentration of the solution. Concentration of the solution is equal to mass of solute divided by mass of solution into 100, that is equal to mass of the solute, here it is 36 gram, divided by mass of the solution 136 gram into 100. If you are going to calculate this problem, you get the answer as it is 26.4. Therefore, the concentration of the solution is 26.4%. So these are the very easiest problems that may come in your examination for 1 marks or 2 marks. You have to remember both the formulas. If they are going to give the volume of the solution here, they are going to change its the volume. If they are directly give the value of the solution and give the mass of the solute, so you are going to calculate the concentration of the solution by using this formula, mass of the solute divided by volume of the solution into 100. You have to remember these two formulas. Next I am going to explain here another type of the mixtures, that is nothing but the suspension. What are suspensions? Suspension. Suspension also, these are also the type of the mixtures, but these are heterogeneous mixtures. Then what type of the mixtures here? What is meant by the suspension? See here, it is a heterogeneous mixture. Suspension is a heterogeneous mixture in which solute particles do not dissolve but remains suspended in the bulk of the medium. For example, I am taking here mixture of wheat flour and water. Under one example I am taking here mixture of sawdust and water. See, what is suspension? Suspension, it is a heterogeneous mixture in which the solute particles do not dissolve but remains suspended in the bulk of the medium. So in the definition, first it is going to be said it is a heterogeneous mixture. Heterogeneous mixture means the solute particles doesn't dissolve completely. So what here it is suspension, it is a heterogeneous mixture in which the solute particles do not dissolve but remains suspended throughout the bulk of the medium. They are present throughout the bulk of the medium. They are present everywhere in the solvent. You have to remember, for example, mixture of wheat flour and water. So you have to take one beaker, pour some water to it and pour some amount of the wheat flour. If you are going to see the wheat flour in the water, it is clearly we can observe that the wheat particles, they are present in the bulk of the medium. They are present everywhere in the water. You have to remember. So such a type of the mixtures are going to be called as a suspensions. Is it clear? What is suspension? It is a heterogeneous mixture in which the solute particles are suspended throughout the bulk of the medium. The solute particles do not dissolve in the solvent. They are present everywhere. They are present everywhere in the bulk of the medium. That is known as the suspension. Another one example here I am taking mixture of sawdust and the water. So if you are going to mix the sawdust in the water, the sawdust it is not going to dissolve in the water. The particles of the sawdust will be suspended throughout the bulk of the medium. Then this mixture it is going to be called as a suspension. Then what are the properties of the suspension? Properties of the suspension. Properties of suspension. Properties of a suspension. First one it is, the first property it is a heterogeneous mixture. First property is it is a heterogeneous mixture. It is a heterogeneous mixture. It is a heterogeneous mixture means what it means? It means the solute particles doesn't dissolve in the solvent. Second one, see here. See, it is heterogeneous mixture in which solute particles does not dissolve but remain suspended in the bulk of the medium. That means the solute particles can be seen by naked eyes. So in the suspension, the solid particles doesn't dissolve in the bulk of the medium. They doesn't dissolve in the solvent. Therefore, we are going to easily see the solid particles which are present in the solution in a suspension. It is another one property. Next one is here, if the solute particles they can be seen easily, then they can scatter the ray of light. See, solute particles scatter ray of light passing through it. If you are going to put the mixture of wheat flour and water in a dark room, if you are going to pass the ray of light through this mixture, the solid particles are the solid particles are nothing but the flour of the wheat. This wheat that going to be scatter the ray of light. What it means? Because when the ray of light passing through the solution, so solute particles which are present in the water, they are going to oppose the ray of light passing through it. So therefore it scatters the ray of light. Is it clear? Because the size of the solute particle it is very big here. We can see by the naked eyes. Therefore it scatters the ray of light. Is it clear? So another one property of the suspension here is solute particles scatters the ray of light passing through it. And next property, if you left undisturbed if you left undisturbed, the solute particles settle down at the bottom. So another one property of the suspension here. So solute particles present in the suspension, if you are going to left undisturbed that the mixture which is contained in the container, if you doesn't disturb that container, the solute particles which are present in a mixture, they are going to get collected, they are settled down at the bottom. Is it clear? Why? Because they are not dissolved completely in the solvent. Is it clear? So under one property of the suspension here, if you left undisturbed, the solute particles settle down at the bottom. The solute particles are nothing but here the sawdust or the wheat flour. If you are going to left undisturbed that the container which contains the water and flour, after 5 minutes or after 10 minutes, the mixture contains the solute particles. That solute particles are going to be settled down at the bottom of the container. Is it clear? So another one here thing is here, when the solute particles are settled down, the upper part of the solution or upper part of the suspension doesn't scatters the ray of light. Is it clear? When the solute, I am considering here a beaker. It contains mixture of water and wheat flour. If you left undisturbed, all the solute particles which are present in the mixture, they are going to be settled down at the bottom. After the solute particles, when they are settled down at the bottom, if you are going to pass the ray of light, it doesn't scatters. Why? Because all the solute particles which are present in a water, which are suspended throughout the bulk of the medium, they are get collected at the bottom of the flask. Therefore light passes at the upper part of the mixture. It is a clear water, therefore water doesn't scatters the ray of light. Is it clear? So under one property is here, after solute particles settle down at upper part of the mixture, after solute particles settle down at upper part of the mixture, if we pass a ray of light, it doesn't scatter. It does not scatter. So what it means? The upper part of the suspension, after the solute particles settle down at the bottom, this upper part, if you are going to pass the ray of light through the upper part, this upper part doesn't scatters the ray of light. Why? Because the scattering of the ray of light due to the solute particles present in the bulk medium of the suspension. So when you are going to left undisturbed, the solute particles which are present in the suspension, they are going to get collected, they are settled down at the bottom. So water will be very clear when you are going to pass a ray of light at the upper part of the suspension. After the settle down, it doesn't scatters the ray of light. It is another one property of the suspension. So what are the examples for the suspension here? Mixture of wheat flour and water, and mixture of sawdust and water. These are the two examples for the suspension here. Next, I am going to consider another one type of the mixture here, that is nothing but a colloid. What is colloid? What is a colloidal solution? Colloidal solution. Colloid or a colloidal solution. What is colloid? See here, colloids are heterogeneous mixture in which the particle size, the solute particle size is too small to be seen with naked eyes. But the particles does not scatters, but the particles scatters the ray of light. See here, what are the colloidal solution here? It is also a type of heterogeneous mixture in which the solute particles, the size of the solute particle is very small. They can't be seen by our naked eyes. What is the difference between suspension and colloid here is, in the suspension the size of the solute particles is very large. We can easily see the solute particles by our naked eyes. But when you are going to consider the colloidal solution, in the colloidal solution the solute particles which are dissolved in that solution, that solute particles, the size of the solute particles is very less. We can't see that solute particles which are present in the solution, because the size of that solute particles is very less. Therefore, and also if also the size of the solute particle is very less, that solute particles also can scatters the ray of light here. What is colloidal solution here? Colloids are the heterogeneous mixture in which the solute particle size is too small to be seen with the naked eyes, but also the particles scatters the ray of light. So here the solute particles, the size of the solute particles is very less, and also the solute particles, they are going to scatters the ray of light. What are the examples here? Examples: few drops of ink in water. If you are going to drop a few drops of ink in water very slowly, it doesn't mix very clearly with the water, it doesn't dissolve completely in the water. We can see the ink particles which are present in the water, it doesn't mix up with the water, isn't it? Such a type of the solutions are called it as a colloidal solution. If you are going to drop a few drops, 2 to 3 drops of milk also into the water very slowly with the edge, if you are going to drop the ink solution or the water drops with the edge 2 to 3 drops with very slowly. We can see here they are not mixed up with the water. Why? Because it is an heterogeneous mixture. So that type of the solutions are called as a colloidal solutions. What is colloidal solutions here? Colloidal solutions are also a heterogeneous mixture in which the solute particles which are present in the colloidal solution, the size of that solute particles is very small, and also they scatters the ray of light. Such a type of solutions are called as a colloidal solution. So example here, few drops of ink in water and few drops of water in few drops of milk in water. These are the two examples for colloidal solution. Then what are the properties of the colloidal solutions? Properties of colloidal solution. Next we are going to see properties of the colloidal solution. What are the properties of the colloidal solution? See here, in the definition it says it is a heterogeneous mixture. That means the solute particles doesn't dissolve completely in the solvent. So it is a heterogeneous mixture. That is the first property of the colloidal solution. Then second one is size of the solute particles is very small. The size of the solute particles which are present in a colloidal solution, it is very small. We can't see it by the naked eyes. That is the second property of the colloidal solution. And the third property, it is a most important property that differentiates the colloidal solution from the suspension. Why? Because in the suspension the solute particles are going to be seen by the naked eyes and they are going to be settled down at the bottom of the container if you are going to undisturbed. But in the colloidal solution, if you left undisturbed the colloidal solution, the solute particles does not settle down at the bottom. So the third property here, the solute particles do not settle down if left undisturbed. If you are going to left undisturbed the colloidal solution, the solute particles which are present in the colloidal solution, they doesn't settle down at the bottom. And another one property of the colloidal solution here, as we know already, the solute particles which are present in the colloidal solution, the size of the solute particles is very small, but also it scatters the ray of light. It is a very important. Solute particles present in colloidal solution scatters the ray of light. In the colloidal solution, the size of the solute particles is very small. They are very tiny. We can't see by our naked eyes. But also that solute particles which are present in the colloidal solution, they are going to scatters the ray of light. Is it clear? So yeah, as I told already, the size of the solute particles is very small, but also it scatters the ray of light. And this effect it is nothing but the Tindal effect. So it is another one property of the colloidal solution. Next we are going to move to the Tindal effect. What is Tindal effect here is the scattering of ray of light when it is passed through the colloidal solution is known as the Tindal effect. Why? Because in the colloidal solution the size of the solute particles is very small, but also it scatters the ray of light. This effect it is known as the Tindal effect. What is Tindal effect? The scattering of ray of light when pass through a colloidal solution. The scattering of ray of light when passed through a colloidal solution is known as Tindal effect. So it is very important for your examination. In your examination, 1 marks question will be asked on this. What is Tindal effect? The Tindal effect, it is nothing but the scattering of ray of light when it is passes through a colloidal solution is known as the Tindal effect. Why? Because why it is going to be considered as special? Because in a colloidal solution the size of the solid particles is very small, but also it scatters the ray of light. This effect, it is known as the Tindal effect. So in this session we discussed about the concentration of the solution. So what is solubility, concentration of the solution, another one type of the mixture, that is nothing but the suspension, properties of the suspension, and also we discussed what is colloidal solution and also what are the properties of the colloidal solution. In next session we are going to continue, we are going to study how we are going to separate the mixture. These are the heterogeneous mixture, isn't it? How we are going to separate these mixture one another. So we are going to continue in the next session to how we are going to separate the mixture in the next class. Okay, thank you.